Okay, we are starting with chapter 4.1, which is talking about radian and degree measure. So if we're just talking about an angle in general, this is what an angle looks like. The vertex is where these two lines meet, the two rays meet, I should say. This is our vertex. The initial side is always the horizontal, and the angle is going counterclockwise. So this is our initial side. And then the angle counterclockwise ends up at the terminal side. Terminal meaning finished, so our angle is done when we get to that end. The ways that we measure angles, we have 360 degrees in a circle if we're measuring in degrees, and two coterminal angles have the same initial and terminal sides. So let's just start by finding different coterminal angles to 150 degrees. Coterminal angles are found by adding and subtracting 360. So if I want to find a positive angle that's coterminal, I would just add 360 and it would look exactly the same, but it would be obviously a lot bigger. 150 plus 360 is 510, so that's our positive coterminal angle. And then we subtract 360 for the second one and get negative 210 degrees for our second coterminal angle. Complementary angles, you guys have heard of these several times by now at this point, so we should know that complementary angles add up to 90 degrees. So if I wanted to find a complementary angle to 37, I would think about what I have to add to 37 to get 90. So in general, you're just going to subtract your angle from 90, and I would get 53 degrees in this case. So like complementary, supplementary is the same, only with 180 degrees instead of with 90. So if I wanted to find a supplementary angle to 68, I want to know what I have to add to it to get to 180. So I would just do 180 minus 68, and the angle that makes this supplementary would be 112. Radian measure. So we haven't done anything with radian measure. I don't think you have it all in geometry. But a radian is just another way of measuring an angle, and that's one we're going to be dealing with most. It's a measure of a central angle theta that intercepts an arc S equal in length to the radius r of the circle. So I'm going to draw a picture that represents that here. My best freehand circle, not the best. So here's our angle theta, right there. This is our radius. Both of these are obviously the same. And they're saying that our arc length here, S, is the same as R. So theta is just how we're going to measure our angle here. Instead of having 360 degrees like in a circle, with radian measure, we have 2 pi in one revolution. So if we have 2 pi in one revolution, that means that a half revolution, or which would be 180 degrees, is pi. A quarter of a revolution is pi over 2, and a sixth of a revolution is pi over 3. So now we need to figure out how to convert between degree and radians. If 360 is the same thing as 2 pi and 180 is the same thing as pi, what you're going to do is to convert from degrees to radians, you're going to multiply by 180 over pi over 180, sorry, for degrees to radians. And from radians to degrees, you're going to do 180 over pi. So an easy way to think about this is whatever you're trying to get to, so result, needs to be on top. So since on the first one we're trying to convert degrees to radians, we want the radians to be on top. Same thing here, we're trying to convert from radians to degrees, so the degrees has to be on top. So that follows both, if you can't remember which way the conversion fraction goes. Okay, so let's do a couple examples converting quickly. 135 degrees. If I want to convert 2 radians, I have to have the radian on top of my conversion fraction. So pi over 180. I would simplify the fraction. I never turn this into a decimal or multiply the pi through. Pi should always be in my answer in radians. So this would be 3 pi over 4 radians. Negative 270 multiplied by the same conversion fraction or ratio, whatever you want to call it. simplifies to negative 3 pi over 2 radians. Now going the other way, if I start with negative pi over 2 and I'm wanting to convert it to degrees, then I use the 180 over pi for my conversion fraction. The pi's cancel, so this is negative 90 degrees. And our last example over here. Multiply by 180 over pi since I want degrees in my answer. Pi's cancel, and simplifying I get 810 degrees here. Okay, so just in general we know the quadrants go around 1, 2, 3, 4 like that. Now as far as our angle measures go, that's 0 radians or 0 degrees here at the horizontal, if that's how big our angle was. At between 1 and 2, that vertical line there, that's 90 degrees or pi over 2 radians. You need to become comfortable with these and understand these. The horizontal over here is 180 degrees or pi. And the last vertical is 270 or 3 pi over 2. And one full revolution would be 360 degrees or 2 pi. Okay, so understanding where those are the most important angles, the verticals and the horizontals. Understanding those will help you understand angles in general. So now the last thing we're going to talk about is arc length. And to find arc length, we have to be in radian measure of our angle. If you have a degree angle, you have to convert it to radians before you can convert arc length. So the arc length equation is S equals R times theta. S is arc length, R is radius, theta is our angle in radian. And then this one up above is just rearranged. So if I ever wanted to solve for the angle, I knew the arc length and the radius, I could just use that form of the equation. So let's find the arc length where we have a radius of 4 inches and the central angle is 240 degrees. What you want to do is make sure that we convert this angle to radians first. Multiply by pi over 180, and that's 4 pi over 3 in radians. Now we have the S equals R theta equation. So S equals R is 4 times 4 pi over 3, which is 16 pi over 3 inches. And I would say it doesn't make sense to leave it that way. If I'm trying to figure out a length of something, not just an angle, I would probably multiply the pi in and get an approximate answer. Our approximate answer here is 16.76 inches. Okay, so this is kind of going back to something we did earlier, but I just wanted to do a couple calculations in radians before we stop, because we're used to doing everything in degrees, so showing you how to do this in radians would be very helpful. So coterminal angle for 2 pi over 3, remember I was saying that we want to add and subtract 360? Well, in radians, we need to add and subtract 2 pi. So I say the easiest way to do this is to get a common denominator. 2 pi is the same thing as 6 pi over 3, and then this is 8 pi over 3. Instead of struggling with fractions, just doing those common denominators right away is going to be the easiest thing. So this ends up being negative 4 pi over 3. And supplementary angle, we know that they add up to 180 degrees. And we know that 180 degrees in radians is pi. So to figure that out, we have pi over 4 plus something is our pi. So what would I have to add to pi over 4 to get to pi? I would have to add 3 pi over 4. And of course, I could always subtract the angles and find a common denominator, as I did up above for the coterminal angles. And that is section 1 of chapter 4.